Now let's share. Growing. All right. Sorry, I have to. For some reason, I have to sign in. I see there's a message in this chat. Ah, thank you, Jennifer. Okay, I got you. Thank you. Thank you. All right. So I guess we can start. So actually, so last week, I think we were in the section 1.8, right? Inverse functions. I think we didn't finish. There's an exercise where you have to find the inverse, right? And I think we didn't finish that exercise. Okay, so let me just remind you. So this is again section. I mean, we are almost done with this section 1.8. There's probably one more remark, and then we can move to the next section. All right. So yeah. So this is inverse functions. So last week, guys, I showed you how to find the inverse of a function. But first, let me just quickly remind you the definition, right? So just remind you what's the inverse of a function f. Oh yeah, by the way, guys, homework number 5 is due today, right? So please don't forget your homework number 5. So it's due today, right? Yeah. So yeah. So just let me remind you the definition of inverse of function f. So so the inverse of a function f of x is, oh well, the inverse of a function is a function, right? So it's a function. Let's call such function g of x. So it's a function g of x such that g of x satisfies the following. So you need f composed with g of x. Again, guys, this is not multiplication. This is a composition, right? Composition. So f composed with g of x is equal to g composed with f of x is equal to x, right? And we denote the inverse. So the inverse function by, so this is g of x is denoted by f to the power -1 of x, right? And so we said that this inverse g, or f to the power -1, is not, it's not the reciprocal of f, right? In general, it's not the reciprocal of f. And I showed you last week how to find, you know, the steps, how to find the inverse, right? So so let me just remind you quickly the steps. Not yet, Jennifer. So for the review tomorrow morning, I mean, instead of the homework number 6, I'm gonna post the review sheet for tomorrow, right? So it's gonna be for tomorrow morning, all right? So yeah, I was saying, so the how to find the inverse. Right, so so we said the main steps are the following. So the steps So first, you replace f of x by y. 2, you interchange x and y. And then 3, we solve for y, right? So then 3, we solve for y, right? So those are the main steps to find the inverse. So we had an exercise. So I think we had some exercise. So we had to find the inverse of the following function. So find the inverse of so first function, I think it was, please correct me if I am mistaken. So, so number 1, 2, 3. So first function was f of x equals to 3x plus 1. And then the second function, I think, was 4 over x. And then we had like plus 1. And then third function is, I think it was 5 minus x over 1 plus x. Okay. Right. So I'm not sure which. I think we solved the number. I'm not sure actually, but I think we solved number the third. The problem number the third function. But anyway, so let me probably just go over again the number 2 and 3. All right, so number 1 is kind of, I think we had a couple of examples similar to number 1. So probably I'm gonna just go over again number 2 and 3, but I'm not sure actually which one I solved last week. But anyway, so for for number 2, so here's your f of x. It's 4 over x plus 1, right? So step 1, no problem, Khadija, thank you. So step 1, we said that we replace f of x by y. So we substitute, so first, step 1, so we substitute f of x with y. So we're gonna have y equal to 4 over x plus 1, right? And then second step, we have to interchange x and y. This is step number 2. So interchange x and y. X and y. So so here in this example, so then this y here becomes x. So that will be x equals to 4 over, and the x becomes y. So this x here, so this x becomes y. So here is going to be y, and then there's a plus 1. All right. Now we have to solve the last step, step 3, which is, I mean, I would say the main step is the last step, where we have to solve for y. So sometimes it's not actually, again, it's not, you cannot, sometimes it's not really obvious to solve for y, right? So sometimes it's not possible to solve for y. But yeah, so let's see what happens here. So you want to solve for y. So the first, so you have, x 4 over y plus 1, right? Well, first you want to get rid of this plus 1, right? So we're going to just subtract 1. Now, so it's going to be x minus 1 equals to 4 over y. So 4 over y. All right, now we are in kind of trouble because our y is in the denominator, right? So what we're gonna do, wanna move this y to the top, right? And to move the y to the top, what we can do is we can flip our fraction here. So if you flip this fraction, okay, then you can move your y to the top. But the thing is, again, when you have an equation, right, wherever you do to one side, you have to do the same to the other side. So if you decide to flip the right side, then you have to flip the left side, right? But the left side, it doesn't look like a fraction, but you can make it as a fraction, right? So you can just, if you divide the whole thing here by 1, it's still the same thing, right? It doesn't change the left side if you divide by 1, right? X minus 1 over 1 is still x minus 1. So now you made it look like a fraction, and so you can flip it now, right? So now it's going to be, if you flip both sides, then you're going to have 1 over x minus 1, and here y over 4. Okay, so now we are almost done because, well, the right side I have y over 4, so y divided by 4. So we want to get rid of this, the division by 4. So you're going to multiply, right? So you multiply by 4 here. So we multiply by 4. And again, because I multiplied the right side by 4, I have to multiply the left side also by 4, right? Once you multiply the right side by 4, then you're gonna have like a 4 in the top and a 4 in the bottom, in the denominator, and so they cancel out. The 4 cancel out, and so you get your y, right? So it's 4 times 1 over x plus 1. So 4. It's 4 times 1 over x minus 1 equals to, and of course, when 4 cancel out here, it means actually you are left with 1 in the denominator. It's not 0 in the denominator, right? It's because it's like 4 times 1. So it's like 1 left in the denominator. Then y over 1, of course, it's just y, right? So this is on the right side, it's just y, right? So, so then your y is actually, equal to 4 times 1, that will be 4, and then over x minus 1. Right, so yeah, so we succeed to solve for y. So this would be your inverse function. So f inverse. So this is the final answer. So f inverse is 4 over x minus 1. So this would be your final answer. All right. Is there any question, guys? Can I move it to the other side? Yeah, sure. Other side. You mean to the right side, like, or to the left? This side. Okay.
Okay. In the exercise,
yeah.
instead of flipping it, can you move the y over to the other side?
So what do you mean by moving y to the other side? Like
where you have 4
multiply?
over y, right? Yeah, you put the x minus y in brackets and you put the y outside.
You mean like you multiply here, like by y here and by y here? Is that what you mean?
No. Okay.
No. Okay. So
okay, well, yeah. Because the y will cancel the y there, and the y is gonna be over there.
Yeah. So that.
Yeah. Can you do it?
Yeah, we can. Yeah, we can do that too. Yeah, sure. You can. Yeah, you can multiply like both sides by y, and yeah, you can do that too. Yeah, sure. It's the same. It's the same. You're gonna have, of course, you're gonna get the same answer, of course. Yeah.
Okay.
You can do that too. Yeah, sure. Yeah. Is there any other question, guys? Okay, so no questions. Good. So now let me go over number 3. The third function, f of x equals to 5 minus x over 1 plus x. So this is Okay. Okay. So for number 3, it's f of x. So we said it's 5 minus x over 1 plus x, right? So so step 1, we said we're gonna have y equals to 5 minus x over 1 plus x. Just replace f of x by y. Step number 2, you would interchange x and y. So step number 2, interchange x and y. So it's going to be x, y becomes x, 5 minus, and x becomes y. So 5 minus y over 1 plus y. All right. And now in the last step, we're going to solve for y. So step 3. So here, guys, I mean, the thing here is that, I mean, we have y in the numerator and also in the denominator, right? So, I mean, if you flip, let's say if you flip the right side, all right, then you're gonna still have a y in the denominator, right? Even if you flip the fraction, right? Because we have y in the top and in the bottom. So it doesn't, if you flip it, then you're gonna still have y in the denominator. So we won't flip this time, but what we're gonna do, we're gonna cross multiply. So this is like a rule. You know, if you have two fractions, two equal fractions, like if you have like a over b equals to c over d, then when you cross multiply, okay, so you can cross multiply. So then your a times d would be equal to c times b, right? I mean, so because that's because the ratio is the same. When you say a over b is equal to c over d, it means that the ratio is the same. So when you cross multiply, you still have an equality, right? So here, so what I'm gonna do, I'm gonna cross multiply, but of course the left side it's x, and again you can make it a fraction by dividing by 1. So if you divide here by 1, it becomes fraction, right? And it's still equal to x. I mean, x over 1 is still x. And now I'm gonna cross multiply. So here's cross multiply here. So that will be, you know, x times 1 plus y equals to 1 times 5 minus y, right? So then now let me just distribute. So this is x times 1, so that will be x plus x times y. That's the left side. The right side is just 1 times 5, it's 5 again. And 1 times y, of course, it's just minus y, right? Now, so how do we solve for y? So the idea is the following, guys. You have to move all the y's to the same side, because then you can factor out y, okay? And once you factor out y, then you can solve for y, right? So so I'm gonna move all the y's to the left side and everything else to the right side. So like here, I have a y on the right side, so I'm gonna move it to the left side. So this is minus y, so I'm gonna add plus y. So this is a plus y both sides. So that would be x plus x times y plus y, and then 5 minus y plus y, of course, it's just 0. Now I have my y's, I mean, on the left side, which is good, right? Now everything else, I have to move everything else to the right side. So there's this x here by itself, this x here by itself. So I'm gonna move it to the right side. So I'm gonna subtract x. Oops. So I'm gonna subtract x minus x minus x. Right. So x minus x, of course, cancel out. So this is xy plus y equals to 5 minus x. So you see, guys, All the terms with y are on the left side, and everything else without y is on the right side. And again, the goal is you want to factor out, because now once you have all the y's on the same side, now you can factor out your y, okay, because y would be common factor. So you can factor out y, and here that will be y times, if you factor out y here, then you are left with x, and then there's a plus, this is plus here, right? And then y, so y would be, of course, equal to y times 1, so you need plus 1 here, right? So y times x, that's xy, plus y times 1, that's y, and equals to 5 minus x, right? So you see now, once you factor out y, you can divide by this, this x plus 1. And of course, you have to do the same to the right side. Okay, whatever you do to the left side, you do the same to the right side. So once you divide here by the left side by x plus 1, so then your x plus 1 over x plus 1, it cancels out, right? So then you get y. So then y would be equal to 5 minus x over x plus 1. Right, so of course the final answer would be, so the answer, so f inverse is 5 minus x over x plus 1. So I mean, you see, guys, if you have, whenever you have like an equation with fractions, I mean, there are different ways actually to solve the equation. One way would be like, you can always flip both sides of the equation, all right, or of the equality, right? Or you can also cross multiply. That's another way to solve, fractions. Yeah, thank you, Sierra. I got you. Thank you. Is there any question, guys, about this number, this function f, the number 3?
Yeah. I'd like to know, where did the x plus 1 come from?
Yeah, the x plus 1. All right. So you see, here, you see here, you have x times y, right? So I decide to factor out y. So if you factor out y, then you are left with x. And that's here. That's my x here, right? And then there's a plus. So here's my plus. And then I factor out this y here, all right? This y here. And if you factor out this y, then you are left with, this is like y times 1. So that will be my 1 here. Does it make sense? Okay, so that's why I got that's why I got x plus 1. Perfect. Is there any other question, guys? Okay. Cool. So yeah, so that's how we find the inverse in general. Now, as I said, I think I said it last week, but sometimes it's not. I mean, you cannot always solve for y. Okay, so sometimes it's just impossible to solve for y. So this is a remark. Sometimes we cannot always solve for y, right? Always solve for y, okay? Or sometimes, your y, sometimes y is not a function. So, so for example, so we have this example with the x squared. Example. So if you take f of x equals to x squared, right? and you try to solve. If you want to find the inverse, the inverse. All right. So let's say this is y equals to x squared. That's the first step. You have to change x and y. So y becomes x, and x becomes y. So that's x equal to y squared. And you want to get rid of the square, so apply the square root. Right. So here's my square root. Right here and here. But then, guys, because this is an even power, and it's because it's an even power, then you're gonna need the plus or minus here, right? Because we have an even power, right? So your y, the square here, cancel out. So your y would be equal to plus or minus the square root of x. But then plus or minus square root of x, that's not a function, right? Remember, in order to be a function, right, for each input x, there is exactly one output, right? And here, of course, if you, for example, if your input x is 1, you're gonna end up with two possible outputs, plus or negative 1, right? So this y is not a function, so y here is not a function. Right? So then this function f do not have an inverse. So f of x, does not have an inverse. Okay. So you see, as I said, guys, I mean, sometimes it's just your y is not a function, or you cannot solve for y, so then your function f has no inverse, okay? So some functions, they have no inverse. Some functions, they do have an inverse, so it depends, right? So the question now, how can we determine whether a function has an inverse or not using graphs? So now the question is, so how can we tell whether function f has an inverse using graphs? So the question, so given the graph of f of x, okay, so how can we determine whether f has an inverse? Whether f of x has an inverse. All right. Well, so let's take an example of the graph. So let's take this function x squared, right? So we know that this function x squared does not have an inverse, right? So let's see, let's just take a look to the graph of x squared. So for example, so I'm going to use the same function, x squared. So let's say f of x, here's x squared, and let's graph f. Okay, graph f of x. So this is the graph of x squared. So 1, 2, 3, 4. So this is 1, 4. Let's say this is 1. Here's 2. -1, -2. And then 0 squared is 0. 1 squared is 1. -1 squared is 1. 2 squared is 4. And -2 squared is +4. Right? So let's say this is, so of course it looks like a parabola, right? It's a parabola. Here's my x squared. F of x is equal to x squared. All right. So, so the question again, how can we determine whether this function f has an inverse or not? So the thing is, remember guys, when you interchange you know, when you want to find the inverse of a function, you have to interchange x and y, right? That's our you know, our second step. We said, you know, when you find the inverse, when you find the inverse of a function f, you have to interchange, right? Interchange x and y, right? So if you interchange x and y, remember, guys, I mean, in order to be a function, you know, you need, like, for each input x, there's exactly one output, right? Now, if you interchange x and y, and then you want to check if y is a function, then you know, you have to apply the same rule, right? For each input, there's exactly one output, right? Well, if you interchange x and y, then the rule would be like, for each input, there's exactly one output. So here, so what I'm saying is, so f of x has an inverse, if for each output, okay, for each output that is exactly one input, okay, because if you know, if you are to change x and y, when you say for each output there's exactly one input, then if you're to change x and y, it says like each input there is exactly one output, right? So and so you see, like here for x squared, if you take, for example, let's say output is 4, okay, let's say here y, the output is 4, right? Here's my output y, right? So this output y 4 has how many inputs? Well, you can see here there's this input, first input, which is -2, right? -2, and another input which is +2, right? So you see 4, which is the output 4, has actually 2 different inputs, right? So that's why actually this function x squared is not has no inverse, okay? Because again, we said the rule would be like, you know, for each output, there's exactly one input, okay? And for this output 4, we have 2 possible inputs, right? The -2 and +2, right? So yeah, so this is like a very general statement. So function f has an inverse is if for each output there is exactly one input, okay? And I mean, if you wanna, you can actually you know, use horizontal lines to see whether a function has an inverse. So for example here, you know, if you use this horizontal line, this one here, well, it's going to intersect the graph at 2 points, right? So if you intersect, if your horizontal line intersect the graph at 2 points, it means that this particular output has 2 different inputs, right? So actually that's called the horizontal line test. I mean, if you want to determine whether function f has an inverse, you can use this horizontal line test. So let me write down the horizontal line test. So f of x, so we can use the horizontal line test. Okay, to determine whether f of x has an inverse. Has an inverse. Okay. So So what does it say, this horizontal line test? Well, how does this horizontal line test work? Well, each horizontal line, so if the function has an inverse, then each horizontal line intersect the graph at no more than 1 point. So if each horizontal line intersects the graph at no more than 1 point, then the function f has an inverse. At no more than 1 point, then f of x actually do have an inverse. So then f of x has an inverse. All right. So that's what we call the horizontal line test. So for example, again, like this graph of x squared, if you take, I mean, this horizontal line here, right, intersects the graph at 2 points. So if you intersect the graph at more than 1 point, then the function f has no inverse. So this x squared has no inverse, right? So, well, more examples. Okay, so let's do a couple of examples. So let's have a couple of graphs here. Let's say this is my first graph. Second graph. So let's say I have this. This is let's say the graph of x cubed. So this is, let's say this is x cubed. This is f of x equals to x cubed. And now let's have another function which is, let's say, it looks like a parabola. So let's say you have this. All right, so this is an f of x, graph of f of x. So you want to determine whether f of x has an inverse. So the question here is, does f of x have an inverse? Right. So if you apply this horizontal line test, the first for the first graph, the x cubed, right? I mean, if you take any horizontal line, it's going to intersect the graph at exactly 1 point, right? So it's no more than 1 point, right? Here's 1 point, exit 1 point, right? So in this case, this x cubed has an inverse. So this this function here has. So this function here has an inverse, right? Now, if you take the second graph, and you know, if you take, let's say, this horizontal line here, it's going to intersect the graph at 2 points. That's more than 1 point, right? So at 2 points, then this function f, of course, then this f of x does not have an inverse. Okay. Yeah, so that's the horizontal line test. And again, the idea is, you know, each output, okay, each output has exactly one input, right? So, so that's like if you want your function f to have an inverse, right? So again, so for whenever you have a graph and you want to determine whether function f has an inverse, all you have to do is just use this horizontal line test, right? Is there any question, guys, about this horizontal line test? All right. Okay, so here's an exercise. I'm going to give you a couple of graphs, and you have to say whether the function f has an inverse or not, Okay. So exercise. Okay, so you have to determine whether f of x has an inverse. Right, so okay, so here's first function or first graph. Okay, so graph 1. So this is your first f of x. F of x. Okay, so number 2. Okay, so number 2. Right, so again, f of x, and the last graph. So graph number 3. So let's say here's your f of x. Okay, so let's say here's f of x. Okay. Okay, guys. Yeah. So please use this horizontal line test to see, or to determine whether f of x has an inverse. Right. So I'm gonna give you a couple of minutes to use this horizontal line test and to check whether this these functions have an inverse. Okay. So so any guess for number 1 is does f of x have an inverse? Number 1.
Number 1, f doesn't have an inverse.
Yes, absolutely. So for number 1, yeah. So of course, if you take a horizontal line here, it would intersect the graph at 1 point, which is good. But then, if you try, if you try like this horizontal line here in the top, then it would intersect the graph like at 3 different points, right? So that would be more than 1 point, of course. So so because of this horizontal line here, then this f of x, of course, then this f of x has no inverse, right? So what about number 2?
doesn't
Does
have an
doesn't have an inverse too. Yes, absolutely. Because again, the same reason. Well, here it's okay. You got 1 point. Here it's okay. You have 1 point. But then here in the middle here, if you take this horizontal line, then that will be a problem. You're gonna have like 3 different points, right? Then this is then this function f has no inverse. No inverse. All right. And what about the last one? Yes, yeah, absolutely, Baba. Yeah, so it's, I mean, if you take any horizontal line here, and we would intersect the graph at exactly 1 point. Okay, so here's 1 point. So then this function f, the last one, f of x, has an inverse. So it do have an inverse, so it has an inverse here. Okay. All right. Okay, so that's for the horizontal line test. So I guess we are probably done with this section 1.8. Is there any question, guys? Again, so for this inverse, you know how to check whether 2 functions are inverse of each other. You know how to find the inverse of a function, right? And given the graph of a function, you can use this horizontal line test to see whether the function has an inverse or not. Okay, so yeah, so that's for the section 1.8. So I guess we're done with this section. So for the test, guys, so the whole chapter 1 is going to be in the test, okay, included this section, right? So it's going to be the whole chapter 1. So now we're going to start chapter 2. So it would be, I think, section 2.2, quadratic functions. It's a kind of a short section. And I think, so if we finish this section today, then it's going to be also included in the test. It's a very short section, actually. So yeah, so we are done with the chapter 1. So chapter 1 is in the test. Now let's move to the next chapter, chapter 2. And we're going to start with section 2.2. Okay. And so that's about quadratic functions. So in this, the goal of this section, guys, I'm gonna of course introduce quadratic functions. I mean, I guess you know what's a quadratic function, you know, when, and then we're gonna, well, basically what we're gonna do in this section is try to, graph quadratic functions in general. So I'm gonna show you, I'm gonna give you all the steps, to graph any quadratic function. Right, so quadratic functions. Yeah, but first let me introduce quadratic function. I mean, I guess you know what's a quadratic function. So whenever you have like a function of the form ax squared plus bx plus c, okay, then that will be a quadratic function, right? So functions of the form. So functions of the form so if you have a function f which looks like ax squared plus bx plus c, okay, so functions of this form are called quadratic functions. Quadratic functions. All right, it's called quadratic because, of course, because of the square, right? So our quadratic functions, and so for example, and here quadratic functions, the a with the number a with a non-zero, okay, with a. So your a must be non-zero. This is important. So with a non-zero. Okay, so your a must be non-zero. So this a here must be non-zero, right? So for examples, so if you have you know, f of x negative, 3x squared plus 2x minus 1, right? So your a would be this negative 3, right, which is non-zero. Your b is 2, and this negative 1, that will be your c. Okay, so this f of x is a quadratic functions, right? Because quadratic functions, because I mean, it has this form ax squared plus bx plus c, and the a, of course, is it's non-zero, right? So this f of x is a quadratic function. Now, if you take, for example, let's say your f of x is, let's take 2x cubed minus x squared plus x minus 1, then this is not a quadratic function, right? Because of the power, I mean, the largest power of x here is 3, right? You see, this is a cube. So because of the cube, then it's not, this function f is not, it's not a quadratic function, right? This is not, again, that's because of the power 3, right? So is not a quadratic function. Again, so you need something of the form, you start with x squared, and then, well, next example, let's say if you have f of x equals to x squared minus 1, right? Well, here your a would be, 1x squared. So your a would be 1, right? Then what will be b? B, there's no x, right? Here, you have plus bx, but there's no x. There's no x, right? So then your b is just 0. Yes, absolutely, Karoli. So b is just 0 because there is no x. And then your c is actually this negative 1. So this would be your c, the constant, right? So b is 0, but that's not a problem. If your b is 0, that's not a problem. Your function f is still a quadratic function, right? So this f of x is a quadratic function. If b is 0, that's not a problem. It's still a quadratic function. If c is 0, again, it's not a problem. If you have another example would be, let's say f of x equals to just x squared. Let's just take our favorite function. Let's just take x squared, all right? So here, so what would be a? As we are supposed to have ax squared, so that's again a 1. So here, this is supposed to be 1 times x squared. So your a is 1. There's no x, so it's just 0x. So your b is 0, right? It's like 0 times x. And then there's no constant, so your c is just 0. So c is 0, right? And so this function x squared, it's still a quadratic function, even if your b is 0 and c is 0. It doesn't matter, right? What's important is that your a is not 0. So this f of x equal to x squared, it's actually a quadratic function. So it's f of x is quadratic. Okay, it's still a quadratic function. Now, if you let's say you have, last example, now let's say you have f of x equal to 3x minus 4. All right. Well, here there's no x squared, right? There's no x squared. If there is no x squared, it means like 0 times x squared. Right? There's no x squared, so your a is 0 here. right? Because there is no x squared. I mean, this is like 0 times x squared, right? So there is no x squared. A is 0, and so if your a is 0, all right, then it's not. This is actually not the quadratic function. So this is a linear function. But anyway, so this is not, your a is 0, because a is 0, then this is not the quadratic function. So because a is 0, because a is 0, then f of x is not, it's not a quadratic function. So again, guys, just be careful. So your a must be non-zero. Otherwise, it's not a quadratic function, right? Is there any question about this definition of quadratic function, guys? So you see, this is like, this is here, this is like the general form, ax squared plus bx plus c, but you need your a to be non-zero, all right? Okay, if there's no questions, and so now let's move to the graph of quadratic functions. So graphs of quadratic functions are called parabolas, right? So graphs, so this is that, let's say this is a remark. So remark. So graphs of quadratic functions are called parabolas, of course. Functions are called parabolas. All right. So whenever you have the quadratic function, then the graph of your quadratic function is going to be a parabola, right? So let's take an example. Let's take a very basic example of quadratic function, and let's graph a quadratic function. So for example, let's take examples. So example 1, let's take a very simple example. Let's just take x squared, our favorite function, x squared. All right, and x squared, it means your a is 1, which is good. So your a is 1, b is 0. There is no x, and the constant is 0. Okay, so this x squared, as we said, this x squared is quadratic function, right? This is quadratic. Okay, now let's graph this x squared, and let's take a look to the graph of x squared, right? So so let's graph this x squared. So we said, so this is here. So let's say 1, 2, 1, -2. So this is 1, 2, 3, and then 4, and then so here's 0, 0. Probably I should I should have a bigger graph. So let's take a bigger, a bigger graph. So 1, 2, so -1, -2, 1, 2, 3, and then 4. All right, so 0 squared is 0, 1 squared is 1, 2 squared is 4. -1 squared is +1, and -2 squared is 4. All right, so then this would be the graph of x squared. Right, so it's a parabola, right? So now, if we take a look to this, a close look to this graph, first you see there's this vertex. There's this special point here, this one here. So this point here, it's called the vertex. This is the vertex of the parabola. Vertex of the parabola. All right, this point here. So that's a vertex. And then another remark about this graph is that, so this parabola here opens up, right? So this, so the graph of x squared, so the parabola here, so the parabola opens up, right? So it has this vertex, special point. So this vertex here is actually a minimum, right? This is a global minimum, right? This is like the lowest point in the graph of f of x. So this vertex, it's the vertex here. The vertex is actually a global, it's a global minimum, right? That's the lowest point in the graph, right? That's the global minimum, right? What else? So another remark about this graph is that we have like, it's kind of symmetric, right? It's, you know, it's symmetric about the y-axis. So you see here, if you take this, the y-axis, you know, this line here, this horizontal line, okay, the y-axis. So it looks like your, you know, your parabola is symmetric about this y-axis, right? So we have like an axis of symmetry. This y-axis is an axis of, it's an axis of symmetry. Okay. Like, you know, like the reflection of this point here would be this point, right? About the y-axis. So the reflection of this point would be, you know, this point here. Or if you take this point, then it's gonna go to this point, right? So you have like a reflection about this y-axis. So this is like an axis of symmetry, right? So this is like a, you know, this is a general statement. So whenever you have a quadratic function, then you always have this like an axis of symmetry, all right? Now, if you take instead of x squared, if you take minus x squared. So let's, so this is example number 2. Now, if we take f of x now, if you take f of x equals to minus x squared, okay? So for minus x squared, if you graph minus x squared, so let's graph minus x squared. Oops. Right, so this is 0, this is, let's say 1, 2, negative 1, negative 2, this is negative 1, negative 2, negative 3, and then negative 4. So negative x squared, if x is 0, of course, you're going to have just 0. If x is 1, 1 squared is 1, but then you have negative, so it's going to be negative 1. Same for negative f of negative 1. So f of negative 1, so it's going to be like negative, and then use parentheses with the negative 1, and then x square, right? So that will be, you know, PEMDAS rule, right? So you do the parentheses first, which is negative, and then exponent. So that will be minus exponent. So negative 1 squared, it's positive 1. So that's here, it's 1, right? And there's a negative here, so it's going to be negative 1. Okay. So what I'm saying is that f of negative 1 is going to be negative 1. So here's my negative 1. If x is 2, 2 squared is 4, minus, that will be negative 4. And the same if x is negative 2, negative 2 squared, that's positive 4. But then there is a minus, so that'll be negative 4. Anyway, so for negative x squared, we're going to have like, so the graph would be like this one here. Right? So again, it's a parabola, right? But so you can see here, what would be the difference between this parabola and the previous one? So you see here for positive x squared, yeah, it opens down parallel. Yeah, absolutely. So this one opens up the x squared. Now for negative x squared, it opens down. So this one here, so the parabola here, the parabola opens down. Okay. So why is that? Well, the difference is, you know, what would be the difference between x squared and negative x squared? Well, here your a is positive 1, right? This a here, a is, so a is positive 1, right? And here your a is negative 1, right? So that's actually a general statement. So if a is positive, then your parabola opens up, and if your a is negative, then your parabola is going to open down. Okay, so this is like, it's like a general fact, yeah, a general statement, right? Yeah, so what else? So here again we have a vertex. So there's this point here, this one here, this point here. So this is a special point. So this would be the vertex of the parabola, right? And now, because your parabola opens down, then this vertex would be like the highest point in the graph. So this vertex would be like your global maximum. So here in this case, this vertex would be a global maximum, because that would be the highest point on the graph, right? Okay, so when your parabola opens up, your vertex would be a minimum, right? Your vertex would be like the lowest point in the graph. But when your parabola opens down, then your vertex would be like the highest point in the graph. So it would be a global maximum, right? So anyway, so these like general facts about the graphs of quadratic functions, right? And of course, here you still have the axis of symmetry. So you see here, this would be, again, your graph would be symmetric about the y-axis. You see it here. Well, I mean, my graph is horrible, so that's, but suppose this is, you know, the y-axis is supposed to be your axis of symmetry. So this is axis of symmetry. Okay, and you see your axis, your axis of symmetry, it passes through the vertex, right? And yeah, so anyway, so let me just write down all these general facts. So so whenever you want to graph, so here, so general steps to graph quadratic functions. Okay, so first step, first you need your vertex, right? So you know, whenever you have a parabola, you're gonna have a vertex, right? So we do have a formula for the vertex, you know, to find this vertex. So the formula is the following. So first, we can plot the vertex. Okay, so now the vertex, so the coordinates of the vertex are the following. So the vertex is given by, so here's the formula for the vertex. So the x coordinate would be actually minus b over 2a. So it's minus b over 2a, right? That would be the x coordinate of the vertex. And the y coordinate is just the f of minus b over 2a, right? So what I'm saying, guys, is that these are the coordinates of the vertex. So this is coordinates of the vertex. Okay. So first you plot the vertex, then you need to find the x-intercept. So then, so second step is to find and plot the x-intercepts. So what does it mean? Let me just remind you what I mean by x-intercept, guys. So x-intercept, again, that's the intersection of the graph with the x-axis. And to find the x-intercepts, you are supposed to solve f of x equal to 0. Okay. So again, x-intercept, that's the intersection of the graph with the x-axis. Intersection of the graph with the x-axis. Okay. Next, next step would be to find the y-intercept. Find the y-intercept. So the y-intercept would be in the intersection of the graph with the y-axis. And how do we find the y-intercept? Well, you just evaluate f of 0. Okay, you just evaluate f of 0. Okay. Again, that's the intersection of the graph with the y-axis. Intersection of the graph with the y-axis. Okay. Right. And then your axis of symmetry. We said, so the axis of symmetry is supposed to passes through the, you know, through the vertex. So your axis of symmetry would be, so you can, in the last step, you can draw your axis of symmetry, and the axis of symmetry is given by the axis of symmetry. So the axis of symmetry, guys, is you know, it's a vertical line. Like here, like in this examples, with a minus x squared or positive x squared. In both cases, the axis of symmetry was the y-axis, which is, you know, a vertical line. And so it's a vertical line. Your axis of symmetry is going to be vertical line, and the equation of the vertical line is given by the axis of symmetry, so which is a vertical line. Vertical line, and we said it passes through the point, the vertex. So then is given by, so the vertex, we said the, you know, the x coordinate of the vertex is minus b over 2a. So that will be the same equation for the axis of symmetry. So x equals to minus b over 2a. So that's your axis of symmetry. Right? Anyway, so those are like the general steps how to graph you know, quadratic functions. So let's have an example. Okay, and I will show you how to follow so the steps and to graph your f of x. So let's say, so an example. So let's say f of x. Well, let's say it's just x squared minus 2x plus 1, right? Which is, of course, this is a quadratic function, right? Because we have the square. Your a is not 0, obviously. A is 1, right? Your a is positive 1, your b is negative 2, and your c is positive 1, right? So this is your quadratic function, f of x, and so the goal now is to graph f of x. Okay, so what I'm gonna do now, I'm gonna try to graph f of x. Okay, so to graph f of x, I'm gonna follow those steps here. So first step is to find the vertex. So step one, we need to find the vertex of this function f, right? Find the vertex. Okay, so what's the formula for the vertex? So the formula is, again, the following. So the x coordinate is minus b over 2a. All right, this is my x coordinate, and this is your y coordinate. So the x coordinate of the vertex is minus b over 2a. So the x coordinate of the vertex, it's supposed to be minus b over 2a. So that would be minus, so my b is negative 2, so it's minus negative 2 over 2 times a. A is, of course, just 1, right? My a is 1, so times 1 here, right? So that would be positive 2. Oops. So that would be positive 2 over 2. All right. And so the x coordinate 2 over 2, that would be positive 1, right? So x coordinate. So x coordinate of the vertex is 2 over 2, which is positive 1. All right. Now, what's the y coordinate of the vertex? Well, it's just f of this, the x coordinate. So f of minus b over 2a. So it's f of the x coordinate. So it's f of 1. So f of minus b over 2a. So that's f of minus b over 2a. You know, we said it's positive 1. It's 2 over 2, so it's positive 1. So it's f of 1. And if you compute f of 1, so f of x is x squared minus 2x plus 1. So that will be 1 squared minus 2 times 1 plus 1. So that will be 1 minus 2, negative 1 plus 1, that will be 0. So that's the y coordinate of the vertex. So the conclusion here, so for this first step, the vertex, the coordinates of the vertex, so the vertex, so this is conclusion of the first step. So the vertex would be, the x coordinate, it's positive 1. And the y coordinate, it's f of 1, which is 0. So the vertex is going to be the point 1, 0. Right? Is there any question, guys, about how I got this vertex? Again, you have this formula, minus b over 2a for the x coordinate, and the y coordinate, it's just f of your minus b over 2a. Right? So that's 1, 0. It's the vertex of my parabola. Right? That's the first step. Now, this next step, we said in step 2, we need to find the x-intercept. So we need to solve f of x equal to 0. So step number 2, we need to find the x-intercepts. Again, that's the intersection of the graph with the x-axis, x-intercepts. So we have to solve f of x equal to 0. F of x is x squared minus 2x plus 1 equal to 0. All right, so you have the choice here. It's up to you guys. Either you can use a quadratic formula, or you can just you can also try to factor, right? So let's just use the quadratic formula, right? So let me just remind you here for the quadratic formula. So quadratic formula. Okay, so your x is supposed to be minus b, you know, plus or minus square root of b squared minus 4ac, right, over 2a. So in this case, your x would be minus b, so it's minus -2 plus or minus square root of b squared, so it's -2 squared minus 4 times a is 1 and c is 1 as well, over 2a, so 2 times 1. All right, so then your x is just minus -2, that would be positive 2, plus or minus. Then you have -2 squared, that's 4. 4 minus 4 times 1 times 1, that's 4. 4 minus 4 is 0. So square root of 0, which is just 0, right? Over 2. So it's just positive 2 over 2. So it's positive 1, okay? So my x-intercept, the x is 1. And remember, guys, for the x-intercept, the y is always 0. So then the answer here, remember, guys, your answer should be using the points notation. So the answer, x-intercepts, is 1 and 0, because y is always 0. So here y, for the x-intercept, y is always 0. Always 0 for the x-intercept. All right, I got my solution here, I got 1, right? But then for the y coordinate, it's always 0 for the x-intercept. Right? So that's my x-intercept. Now the y-intercept. So that's the step number 3. Now for the y-intercept, I have to, to find the y-intercept, I have to evaluate f of 0. Find f of 0, right? Evaluate f of 0, which is, of course, 0 squared minus 2 times 0 plus 1. Right? So f of 0, it's just positive 1. All right? So then the answer, the y-intercept is, so I got 1, right? F of 0 is 1. Okay, so here's my 1. But for the x, again, your answer should be, you should use the points notation for the answer, for the y-intercept. So the x would be always 0. All right, so x is always 0 in the y-intercept. Okay, so x is always 0. All right, so that's my y-intercept. I have so 0, 1 is my y-intercept. Now, last step. So step 3 was the finding the y-intercept. Now, step 4, I have to find the axis of symmetry, and the equation again of the axis of symmetry is just as the vertex minus b over 2a. Okay, so the axis of symmetry of this, again, the axis of symmetry is going to be a vertical line, and it's just, so step 4, the axis of symmetry of symmetry. So the equation, we said it's x equals to minus b over 2a, which is the same as, so it's the same as the for vertex, like minus b is -2 over 2 times 1. So that's positive 2 over positive 2, so that's positive 1. So it's x equal to 1, right? So here, at axis of symmetry, it's x equal to 1. Okay, so this is like, that's the answer for the axis of symmetry. All right, so now I have everything I need to graph my function f. All right, so let's plot all these points and draw the axis of symmetry. So now let's graph. So now let's graph f of x. Okay, so again, f of x was, you know, x squared minus 2x plus 1, right? So I'm going to graph now f of x. Oops. Okay. All right, so this is 1, 2, 1, 2, etc. You know, -1, -2, etc. All right, so first I have to plot the vertex. So the vertex, we said the vertex is 1, 0, right? The vertex is 1, 0. So let's plot 1, 0. X is 1, y is 0. So x is 1 and y is 0. So this would be the vertex. All right, so here's my vertex. All right, that's my vertex. And then, so for the axis of symmetry, the axis of symmetry is the same as the x is the same as the vertex. So my axis of symmetry is just the same. It passes through the vertex. So my axis of symmetry would be this line here. It's a vertical line. So here's my axis of symmetry. It's a vertical line which passes through the vertex. This is my axis of symmetry. It's the vertical line passing through the vertex, the axis of symmetry. Okay. So it's, again, axis of symmetry, we said the equation is x equal to 1, right? Here's my axis of symmetry. So this is x equals to 1, right? It passes through the vertex. Now, I'm gonna plot the x-intercepts and the y-intercept. So x-intercept, it's 1, 0. X-intercept is the 1, 0. Well, it's the same as the vertex. So this is also my, the vertex is the same as the x-intercept. It's 1, 0. All right. Now, the y-intercept, it's 0, 1, right? The y-intercept, it's 0, 1. So 0, 1. So here is, this is 0, and then here's 0, 1. That's my y-intercept, all right? Now, guys, so because, you know, this f of x, it's x squared minus 2x plus 1. So the a here is positive, right? So a is positive. So when it's positive 1, right? So if a is positive, then the parabola opens up, right? If a is positive, so it opens up, right? So, you know, so this is supposed to be my vertex, and my parabola opens up. So I'm gonna go up, of course. So this is my vertex, and I'm gonna go up here, right? And then, of course, because, you know, I have this, you know, yellow line, it's my axis of symmetry. So it's supposed to be symmetric about the axis of symmetry. So we're gonna have, on the other side of the axis of symmetry, we're gonna have the same thing here. Right? So that would be the graph of f of x. And again, you see here, because it's the axis of symmetry, so it's supposed to, you know, like this point here, reflection of this point about the axis of symmetry should be this point, like this point here should go here, you know, etc. Right? So that would be, of course, that would be the graph of f of x. Okay, so again, guys, all you have to do is to plot the vertex, x-intercept, y-intercept, check your A. Again, if A is positive, then it's gonna open up. If it's negative, it's gonna open down, right? And then just, try to connect your points, and you're gonna get your parabola. Is there any question, guys? All right, so if there are no questions, then, so I'm gonna give you a couple of quadratic functions, and then you need to try to graph the functions, right? So again, all you have to do, guys, try to follow here. Basically, we have these 4 steps. Find the vertex, next find the x-intercept, then find the y-intercept. The axis of symmetry is gonna be the same as the x coordinate of the vertex. And then, just plot the points and try to connect the points, right? Okay, so exercise then. Exercise. So please try to graph the following functions, or graph the following. Okay. So for number 1, let's say you have f of x equals to, let's say, x squared minus 4x plus 6, right? And number 2, f of x, it's let's say minus 2x squared minus 12x plus 3, right? Okay, guys, I'm gonna give you probably 5 minutes and to graph these functions f, right? And of course, if you have any questions, just let me know. Sorry, this is not plus 6. This is supposed to be plus 3. I'm sorry. Plus 3 here. So I mean, I changed it because it would make the computations easier. here probably, or also for number 2, I would change it to, sorry. So let me just change it to plus 5x and then minus 3. So let's say minus 3 here. So again, guys, for the review, the review sheet, I will post it tomorrow, tomorrow morning. Okay, and again, if you have any question about the homeworks or about the review sheet, so we're gonna meet on Monday, of course, and just prepare your questions, and if you have any, and yes, yeah, Carly, yeah, homework 5 is due today, absolutely, yes, yeah. Mm-hmm. So material for the test, so it's going to be chapter 1 plus, because actually we are done with this section. That's all for this section 2.2. I mean, as you can see, it's a very short section. So yeah, so the material is going to be chapter 1 plus this section, right? Okay, I mean, we have probably 2 minutes. Well, I mean, yeah, probably don't have enough time to solve both, to graph both functions. But let me just say what will be the main difference between number 1, number 2. So you see, guys, I mean, number 1, your a is positive. You see, this is 1 times x squared. So this is positive 1. And for the second function, we have a is negative 2, right? So the thing is, for number 1, the parabola, because a is positive, then this one here opens up, the parabola opens up, right? And for number 2, because your A is negative, it's going to open down, right? So the parabola is going to open down, right? So that's the main difference between number 1 and 2. Now, so let's say you want to graph number 2. Let's just do the number 2 in 1 minute. First, you have to find the, step 1, you have to find the vertex. And so the vertex, the x, it's supposed to be minus b over 2a, right? So it's minus b is 5, so it's minus 5 over 2 times a, right? So it's minus 5 over 2 times 2, so it's negative 5 over 4, okay? And then you have to find, that's your x coordinate of the vertex. Your y coordinate, of course, would be f of negative 5 over 4, okay? So you have to plug in negative 5 over 4 in your function f. So it's going to be like negative 2 times, negative 5 over 4 square, plus 5 times negative 4 over 5, minus 3, etc. Right? So then you get your y coordinate of the vertex, right? And then, so that will be probably equal to, so negative 2 times negative 5 over 4 square, so negative 525 over 16, and minus 5 times 5, 25 over 4, minus 3. So it's going to be like, so negative 50, negative 50 over 16, minus 25 over 4, minus 3. And if you multiply, you get common denominator here, right? So that's negative 50 over 16. Here you multiply by 4, minus 100 here over 16, minus 3. Here it's 3 over 1, so we multiply by 16 in the top and in the bottom. So that will be 48 over 16. And then, it's going to be like negative 50. Probably it's not really a good example here, but anyway, so negative 50 minus 100 minus 48. So that will be negative 198 over 16. Anyway, so that's the y coordinate of the vertex, all right? So the vertex, the coordinate of the vertex would be, so the vertex, the x coordinate is negative 5 over 4, and the y coordinate would be negative 198 over 16. Anyway, so once you, probably I don't have time, I'm sorry, I went over time, but so first you have to plot this vertex, then you have to, find the x-intercept, y-intercept, and then, then you can graph your function f. But anyway, so probably I'm gonna do this next in the review on Monday. I'm gonna do probably 1 or 2 examples, graphing parabolas on Monday. And yeah, so I'm gonna stop here probably because it's I went over time, so I'm gonna stop here. So I will see you next Monday, guys, and please let me know if you have any question or any problem. Okay, thank you. See you next time.
Thank you, Professor.
Thank you. Take care.